All right, guys. We are finishing the note sheet from yesterday. Finish up the notes from yesterday. So what we finished off with yesterday was the sum and difference of perfect cubes, or sum and difference of two cubes. Now, the nice thing with the sum and difference of two cubes with factoring is that there's a set pattern, just kind of like a difference of perfect squares for how these work. Now, the first thing we need to do is find our A and B terms, our cube root terms for our two spots. Yes. We did this one? All right. So we'll look at this one here. X cubed minus 64. X cubed minus 64. Now, all right, yes. I think it's Caden's. I don't have any extra copies. Everybody took them, so at least that one's pre-filled out. Now, all right, guys, focus in. So what we're looking at here is finding the sum or difference of two cubes. Now, one of the ways we know that it's possibly a sum or difference of two cubes is our x cubed, x to the third. It is going to be helpful to look for a greatest common factor first. Between x to the third and 64, there is not one. Now, the next thing we're going to do is check and see if they are indeed, or if there is a number that will multiply by itself 3 times, or a term, expression that will multiply 3 times by itself 3 times to get to both of these here. Now, the cubed root of x to the third is x. Now, we also need to find the cubed root of 64. We're trying to find what number times itself 3 times is 64. And it will indeed be 4. So to get the cubed root, we do 3, second, and it is the button above our square root. And when you do that, the 3 should get a little bit smaller, go up. Now, a way that we can check it is, say, 4 to the third power and see if we get back to 64. Because if we do 3 here, because if you notice the 3 did not get a little bit smaller, did not go up into the index, and then we hit enter, it tells me it's 24. Because really what this did is it took the square root of 24, or square root of 64, which is 8, multiplied it by 3 to get 24. So if we check it, 24 to the third power is not 64. So 4 is the answer for that there. Questions on how we found these two terms? So it does tell us two things. One, it's helping us find the values of what we're going to plug in. And 2, it is confirming that this is a difference of two cubes. Now, with sum and difference of two cubes, we still have 2 sets of parentheses. The first one has 3 spaces, and the second one has 5. The first one has 3 spaces, the second one has 5 spaces. Questions on this so far? The signs. The signs are going to be the same, opposite, always end on a positive note. So what we started this problem with is a minus. So it's going to match it. The first one's going to be the same. So our first sign is minus. Opposite. So our second sign is going to be plus. And it always ends on a positive note. So plus. So our signs for this are going to be minus, plus, plus. Minus, plus, plus. Questions on how we got our signs? Let's look at the smaller set of parentheses first, our set of 3. With this here, we're going to put the cube of the first term, our x, in the first spot because it was part of the first term. And we'll put our 4, which goes with our second term, into the other. We just put them there, x and 4. So the first power, we don't have to do anything with them. First term in the first spot, second term in the third spot. That's it for that part. Questions on this here? Now, just like yesterday, I'm going to fill 2 of the extra pieces in. But we're going to start off with our first term, our x. Because in the bigger one, we're going to put that to the second power. In the first spot, in the middle spot, it'll be to the first. And in the last spot, it's to the 0, because the exponent's going 2, 1, 0. It's decreasing. So the second power in the first power in the middle, 0 power in the last spot. Our second term, our 4, in the first spot here, is going to be to the 0. In the middle spot, it's going to be the first. And in the last spot, it's going to be squared. So the first one is going from a power of 2 to a power of 1 to a power of 0. The second term is going from a power of 0 to a power of 1 to a power of 2. So as one is decreasing, the other is increasing. Questions on this here? We ready for the last part? Last thing we got to do is simplify. Now the x minus 4 is already as simplified as it gets. Now the bigger one, the first thing we're going to simplify is this x squared times 4 to the 0. Well, 4 to the 0 is 1. So really what we're saying is that this here is 1. And it's being multiplied by our x to the power of 2. Well, what is x squared? X squared. So really with that first term, what we're saying is we have x squared times 1, which is x squared. So really there's not a whole lot of reason for us to have that 4 to the 0, because it's going to reduce to 1. We multiply by 1. It goes away for all cases and purpose. Plus, in the middle we have x to the first. Well, x to the first power is x. And then 4 to the first power is 4. So really we just have what in the middle? X times 4, which is 4x. And then the last one, well, again, anything to the 0 power is 1. So for our x to the 0, we just have 1 times our 4 squared. Well, what is 4 squared? 16. So really this last spot, we just have 1 times 16, which is, we have plus 16. And that's it. That is one of the nice things with the sum and difference of 2 cubes, is that it's going to factor like this every single time. Questions on this here? We ready for the next one? 27a cubed plus 64. So again, the first big question is, do we have 2 cubic, perfect cubes, 2 cubes? And we can find that by taking the cubed root of both terms. Now with our 27a to the third, well, we can't take or plug the cubed root of a to the third in the calculator. But the cubed root of a to the third is a. And we can plug the cubed root of 27 in, which is indeed 3. Which means the cubed root of 27a cubed is 3a. Cubed root of 64. I think we've already found it today. Found it yesterday, is 4. So that does tell us that this here is a sum of two cubes. And we have our two terms. It would indeed. Our signs are going to be the same, opposite, always end on a positive note. Since we're talking about a sum, for it to be the same, the first sign is going to be plus. Opposite means our next sign is going to be minus. And always end on a positive note means our third sign is plus. So we have plus, minus, plus for this here. Questions on this so far? Our first set of parentheses, we'll put the first term, what we got from taking the cube root of it, our 3a in first. And our second term, 4, in the other spot. So our first set of parentheses is just going to be 3a plus 4. It's those cubics just go right in there. Questions on this here? We ready for the first term in the bigger one? So on the first spot, we're going to have 3a being squared. In the middle, we'll have 3a to the first. And in the last spot, we really have 3a to the 0. But as we just saw, it's going to reduce to 1 and go away. We're just left with the other term. Same thing with 4 in our first spot here. Would technically be 4 to the 0, but that's going to simplify out. In the middle, we'll have 4 to the first. And in the last spot, we're going to have 4 squared. Questions on any of this here? How we plugged any of this in? You ready to simplify? Now the nice part of simplifying all this is the first set of parentheses, because it's just going to be 3a plus 4. Now the first one we're going to simplify in the bigger is 3a squared. We're squaring both terms. So 3a times 3a. Well, 3 times 3 is 9. A times a is a squared. Because we can just go and square both terms. 3 squared is 9. A squared is, well, a squared. In the middle, we have 3a times 4. Well, 3 times 4 is 12. And we still have our a. Plus, our last one is 4 squared, which is indeed 16. Now, the one thing that is interesting about the sum and difference of two cubes is that quadratic part. Here, the 9a squared minus 12a plus 16 won't factor. It just does not factor. Questions on this here? Look at this one. 192x cubed minus 81y cubed. So, what we're looking at is taking the cubed root of 192 x cubed and taking the cubed root of 81 y cubed. Well, with both of these here, the x cubed, the cubed root of x cubed is going to be x, cubed root of y cubed is going to be y. Now let's take the cubed root of 192. Cubed root 192 is this here. Because we have a decimal, it means it's, well, we can't take the cubed root of it. So I'm going to take the cubed root of 81 too, just to make sure. Yep. Before we can say not possible, we need to check for greatest common factor. So, 192, let's try 3, is 64. 81 divided by 3 is 27. So there is a greatest common factor of 3. That is not the 6. That's our 27. And that's our 64. So here we would look for a greatest common factor, and the greatest common factor between these is actually 3. That's the only number that's in common with both. But by taking it out, because 192x cubed minus 81y cubed is not a sum or difference of 2 cubes. But once we factor that 3 out, 64 is a perfect cube. It would be 4. And 27 is also, it would be 3. So 64x cubed root is 4x, and 27y cubed root is 3y. So that does tell us that we do have a difference of 2 cubes. Two sets of parentheses with 3 spaces. Now our signs are going to be what? The same. So our first one would be minus. Opposite would be plus. Always end on a positive note would be plus. Now our first set of parentheses, we'll plug our first term in first, which would be 4x. Our second term would be 3y. In the bigger set of parentheses, we'll do our 4x, our first term first, because in the first spot it will be to the second power. In the middle, the 4x will be to the first power. And in the last spot, it's really to the 0. We don't have to list it. The 3y in the first spot in our bigger set of parentheses is to the 0. In the middle, the 3y is to the first. And in the last one, the 3y is to the second. And last thing we have to do is simplify. So we'll have 3 times 4x minus 3y. In the bigger one, the first thing we have to do is 4x squared. So 4x times 4x, 4 times 4 is 16. X times x is x squared. So our first term will be 16x squared. Plus our 4x times 3y. Our 4 times 3 is 12, and then we have xy. Plus 3y squared. 3y times 3y would be 9y squared. Now with having a variable in both spots, did it really change how we did this? No, still works the same. This is almost in some ways a little bit nicer than our normal quadratic factoring because it works in the set pattern. We don't have to do guess and check. It is this way here. Questions on this here? We're going to do one more. We're going to do this one here. We can actually leave it alone. Yeah. Now, if we were solving, yes, I would want that x up front, but we can leave it where it is. So, cubed root of 125 is 5. And the cubed root of x to the third is x. So we just have these two terms here. It does tell us it is a difference of 2 cubes. And we know our values that we're going to be plugging in. Now our signs for this are going to be the same. Opposite always end on a positive note. So the same, we'd start off with minus. Opposite would be plus. Always end on a positive note, plus. Now for our first set of parentheses, we'll plug in our first and second term in. So the first term would be 5. Our second term would be x. So we'd have 5 minus x. In the bigger one, we'll start off with our first term. So in the first spot, we would have 5 squared. In the middle, we'll have 5 to the first. And in the last one, we really have 5 to the 0. Then for our second term, with our 5 squared, the x would be to the 0. In the middle, x is to the first. And in the last one, we have x squared. And all that leaves is to simplify. So we'd have 5 minus x. First one we have is 5 squared, which would be 25, plus our 5 times x is 5x, plus our x squared as well, just x squared. And that's it. Now, if we wanted to, we could rewrite the quadratic in standard form. So we'd have 5 minus x times our x squared plus 5x plus 25. Also the same answer. But we get this here. Questions on any of this here? That's it.